Okay, Unit 10 review. I'm going to finish it up here on this second one. I just threw my pen though, so I'm going to grab that. Okay, number 9. Are they similar? We know 3 sides from each triangle. If it's easier to separate them to see them, go for it. I'm going to do that. This is 48, 48, and 36. The other one, you have side lengths of 27, 36, and 36. Since we don't know any angles here, it's got to be SSS or nothing. So we're going to check proportionality. Shortest side, 27. Shortest side, 36. 27 over 36. Next shortest side, 36, and I have 2 of them. Over here, next shortest side, 48, and I have 2 of them. So we just have to check and make sure 36 over 48 is congruent to 27 over 36. And when you check it out, you find that this is 3/4 or 0.75, and this is 3/4 or 0.75. So you'd say yes by SSS. They are similar. Number 10, if you look at this figure at the right, is it possible that MP equals 1.8 times QP and NP is 2 times OP? No, that's not possible. They have to be proportional, so the conversion factor must be the same. Conversion factor must be the same. 1.8 does not equal 2. For number 11, are these triangles right? We talked about these in class. Parallel lines. If this is parallel to this, then alternate interior angles, that and that, are congruent. And if this is parallel to this, then these alternate interior angles are congruent. Since I have 2 pairs of angles that are congruent in each one, I'd say yes by AA. They are similar. Number 12, same concept. Each triangle, I have a right angle, and they both share this angle at P, so therefore, they both have 2 angles in common. That is yes by AA. For number 13, are these triangles similar? Got a right angle in each one, and it tells me SW is parallel to SU. As a result of that, alternate interior angles right here and right here. So once again, yes by AA. So know your alternate interior angles. On to the next page. We want to know if ABE is similar to CDE. Well, the answer is yes, and here's why. Vertical angles here, so there's one pair of angles I know. I need one more. Now, because this is parallel, AB is parallel to DC, alternate interior angles actually occur here, and they occur here and here. So you'd say by yes by AA, but really you could say yes by AAA if it existed. We get into the story problems. I'm going to try to draw them. A telephone pole. There's my telephone pole. We don't know its height. We want to know what its height is, but it casts a 10-meter shadow. A person standing over here, here's my person. A person is 1.7 meters tall, and he casts an 84-centimeter shadow. Now that's 0.84 meters. So all we're going to do is set up a proportion here. I'm going to say x over 10 equals 1.7 over 0.84. All I did was height over shadow equals height over shadow. Cross multiply and divide. You should get that the telephone pole is 20.2 meters tall. Next one, we've got an airplane. So there's the ground, and here's the airplane. It's up here somewhere. There it is. It's too small to see in the sky. Let's see. When the ground distance was 1.5 miles, so my ground distance is 1.5 miles. Kind of hard to read. It had an altitude of 2,000 feet. And we want to know how high is this airplane when it has a ground distance of 5 miles. Because that's all the way over there. Once again, proportion. Everything from here on out comes down to proportions. I'm going to say 2,000 over 1.5. So it's height over ground distance equals x over 5. Height over ground distance. Cross multiply and divide. You should get 6,666.66 feet in the sky. Number 17, moving on. We've got the toll booth question. Let's label it first. It tells you that the ramp The whole thing is 2,640. The toll booth is 3/4 of that distance, so if you multiply that by 3/4, you get 1980. That is the distance from the toll booth to the bottom. The height of this first pillar is 360 feet, and the distance to that pillar on the ground is 1948. In part A, we want this pillar, and in part B, we want the ground distance of the entire thing. So just like at the beginning when we had triangles, up here I have both the short and the long. So I'm going to use that as my one side of my proportion. 1980 over 2640 equals height, small height, over large height. So that's how you're going to do the first one. Small over large equals small over large. Cross multiply and divide, and we get 480 feet for part A. For part B, we want the larger down here. I'm still going to use 1980 over 2640 for my reference because I know both parts. Only now my small is 1948, and I want the large down there. This times this, divided by 1980, finds me that that distance is 2,597 feet. And that is the end of that problem. Next one, number 18, very similar question, different situation, but similar question. I'm going to go ahead and label everything that they give me. They tell me that this distance is 4. They tell me that the fence has a height of 6 feet. They tell me this ground distance down here is 10, so that is the distance right there that we know both the short and the long. In part A, and they tell me the whole ladder is a 12-foot ladder. Part A, we want the height of the building. Okay, so just like before, we're going to use, hey, what do we know both parts to? Well, I know 4 over 10, short over long. And for the fence and the building, those are parallel, so I can say 6 over A. 60 divided by 4, we get 15 feet for the height of the building. In part B, we want how far up the ladder reaches when it touches the fence. So that's part B. It's a small. I'm still going to use 4 over 10, but now I'm going to go B over 12 over here. This times this is 48 divided by 10, and you get 4.8 feet for how far up the ladder it touches the fence. For number 19, to find x, this is your side splitting theorem. All you have to do with this is 180 over 160 equals x over 120. Very much a proportion. 180 over 160 equals x over 120. 180 times 160 divided by, 180 times 120 divided by 160 finds that x is 135 meters. Part B might be a little tricky, but you can forget about this altogether and do it very much the same way. 180 over 160 now equals y over 200. Cross multiply 180 times 200 divided by 160 finds you 225 meters to be the length of y. Which gets us to the last question on the whole thing. We want to know what part of the total assessment is paid for the residents of each lot, and they're talking based on their Washington Boulevard frontage. Boulevard is spelled incorrectly, it just occurred to me. So I need to find the frontage of part A and part B. Okay, not a big deal. You'll notice for lot D we know both parts. So to find A, we're going to take Lincoln over Washington and do Lincoln over Washington. So 56 over A equals 224 over 208. A little cross multiplication, divide by 224, and we get that A equals 52 feet. So this is 52 feet right here. But we're not done yet. Part B, I'm going to do this first. I've got 112 over B equals 224 over 208. We'll cross multiplication and divide by 224. You find the frontage for B is 104. Now, I want to know what part of the total assessment. So that means I want to put a fraction up there or a percentage or something of that. If I add all their parts, this is 104, 52 plus 104 plus 156 plus 208, I get a total of 520 feet. Okay? Which means part A is 52 out of 520, which you should recognize as 1/10. And that is our answer for number 20, part A. For part B, we've got 104 out of 520. Well, that breaks down to 1/5. Okay, so your answer here would be 1/5. And you're done.